Hello everyone, hope everyone is doing well. Today in this lecture we're going to talk about Way ANOVA. ANOVA here stands for Analysis of Variance. Even though in this case we're talking about analysis of variance, we're actually testing whether the means of more than two samples are equal or not. So let's say you have, so far what we have done is we have tested that, so we have tested hypothesis where our sample mean was equal to one specific value. We have also tested two sample tests where we have two separate samples, and we tested whether the means of those two samples are equal or not. What if we have more than two samples? That's when analysis of variance comes in, and what we are doing here is we're testing in our null. We're testing whether multiple samples have the same means or if they don't. So maybe we have 5 stores. So we have store 1, and we have the means of these numbers. Now we will test if these numbers are all equal in the and if we have their population estimate. So again, we are not testing x bars. We are actually testing for the population mean mu. So what is this telling us? Let's say we have each of these variables, they have a separate distribution of their variables, and this is their mean 1. Now, we may have another variable. So let's say this one, we are testing, is this distribution close to it like this, or is it far away from it? Now, this is not only for these two variables or these two samples, it also includes the third one. If the third one is also very close to the other two, the distribution is very close to the other two distributions, then we are good. And it does for all of them. So if this is true, then we cannot reject the null because the distributions are all basically almost overlapping each other. On the other hand, if we have something such that, say this is mu1, we have mu2 here, and maybe mu3 is way out here, this shows us that these variables or these samples have very different means. And so then we can say that, well, we probably may not be able to keep the null or accept the null. We have to then reject the null. So again, our null is here, all the means are equal, and the alternative is at least one of them is not equal. So one of them falls out. It could be that all 4 are equal, but sample 4 or store 4 does not, the mean is not equal to the others, then we would reject the null. So how do we do our analysis for analysis of variance? So first we are going to look at how to do it basically in Excel, and we are also going to see how to do the analysis of variance step by step. So let's say we have this data. We have maybe we collected data for a few weeks, and we wanted to see, like, if we have 4 stores, are these means equal to each other? So our null would be the population means are equal, and the alternate is, so we have our null and alternate here. We are going to say that the population means are equal, that's our null, and the alternate is at least one of them is not equal. And so from here we have to find our ANOVA. Now let's look at certain things. So we have store 1, store 2, store 3, store 4. So we can find the mean of each store. So this is the value for each store. And now, so I can see that the averages are all over the place. Store 2 has the lowest, which is 109, and store 3 has the highest, which is 135. So these are the means of each store separately. Now, there's another thing that we have. We call it grand mean. Grand mean would be if we considered all 4 stores to be part of one store and we found the average of all those numbers. So the grand mean would be the average value of all these 4 stores together. So now that we have the mean and the grand mean, now we need to do certain steps. We next need to find these two numbers, the sum of square of among groups and sum of squares within groups. And this is the formula. It looks a little intimidating, but let's go step by step and figure it out. So C here that we have on top, we have this number C. This C is basically telling us that it's going to be, or this number is telling us the number of groups that we have. So C is going to be the number of groups. Here we have 4 groups since we have 4 stores. So in our case here, C equals 4. And what it is telling us for sum of squares amongst group is that we take xk bar, so basically the average of each store. So this number is going to be x1 bar. This is x2 bar. This number is x3 bar. And this number is x4 bar. We are subtracting each of these averages from the grand mean, which this is my grand mean, and it's x bar bar. It has double bars. And we multiply each number by the number of count or number of observations in each group. So we need something before we go forward. So we need a count variable, which would be equal to the count. Actually, let me put count down here. I'll put the average, the formula of the average right here so people can see that. And count will be just counting the number of observations we have. And we have 8. So based on this, what we can do is calculate the sum of squares amongst groups. So the first thing we do is we find for each group, let me just insert a couple of rows here. We will take, first we need the count. So we got the count times, we get the mean, subtract it from the grand mean, and then square it. So we will get a number like 112.5. And just to make it easier so that I can copy it, I put $signs around the grand mean because I don't want that number to move around. And then I'll just copy this all the way across. And then finally, I'll sum. And this will be this number is what we would call sum of squares amongst groups. Or this number is written as SSA. The next is SSW. Now this is, again, it has 2 summations, so it looks a little even more intimidating than the first one. But what we are doing here is first, we are taking each group. There are C groups that I have, so 4 groups. For group 1, what we will do is we will take each number that's in the group, subtract it from the mean. So let us work on it. Let's just work on it maybe right here. So I'll just rewrite this somewhere else. Let me just rewrite it here. So in this case, what I will do is, so first I'll take the number of the store and then subtract the mean that I have down here, and then I'll square it. Now, since this number, I don't want to move this mean around, so I'll just put a $signs around it, and then I will highlight it all the way down. So this number is going to be this value up here. We will do the same thing for all the other 4 or the other 3 stores that we have. So now we have found all these numbers. So again, a recap, we took each of these numbers. So to find, let's say, this number, what we did is we took this number that we have here, subtracted this number, and then squared it. And we did that for every one of them. So to find, let's say, this number, to the color, to blue, to find this number, this is for store 3, I went to this number, subtracted 135 from that number, and then squared it. Now to find SSW, what I need to do is just sum all those numbers. So this is what we would call sum of squares within, or SSW. So now we can make a little table. Okay, let's sum of squares. So sum of squares among is going to be this number. Sum of squares within is going to be that number. And we can also find the total, which is just going to be the sum of these two numbers. After we find that, we need our degrees of freedom. For among, the degrees of freedom is going to be just number of groups minus 1, this here. And for within, it's going to be total count minus number of groups. So for among, the degrees of freedom will be number of groups minus 1, which is we have 4 groups minus 1. For the within, it's going to be, we have, in each number, we have 8 groups. So let us just sum all that and minus the number of groups, which is 4. So we have 28. The next numbers we need to find after that is mean squares. So we call them MSA or MSW, which is just going to be the sum of squares divided by the degrees of freedom. And finally, now the F value or F stat, that's going to be just the mean square among and means divided by the mean square within. So we get a number of 2.87. Now we need to compare this F stat with the critical value of F. So if I would need to find the critical value, I would do F dot INV. We always look at the right tail. Let's say my probability is going to be at 5%. Degrees of freedom, the first one is going to be, since the numerator is mean square among, so it's the degrees of freedom of among, comma, the second one is going to be in the denominator, which is of within, and we get 2.94. So from here, we can now draw our F table, our F graph, and we can see that my critical value is down here, 2.94. Any number to the right of that, this is the rejection region, and any number to the left, this would be the non-rejection region. I find my F stat is at 2.87, which is right here. So it is in the non-rejection region. Our interpretation thus would be that the F stat that we calculated is less than the critical value of F, so we do not reject the null when alpha is 0.05. Another way of doing it, instead of finding the critical value, if I have the F stat, is to find the p-value. The p-value would be just the f dot dist. We are always looking at RT, the right tail. The F stat, comma, the degrees of freedom 1 is going to be 3, and the second one is going to be 28. And we find it to be very close to 0.05, but not exactly less than 0.05. So if we're looking at alpha at 0.05, we would say, and thus we have done our calculation. This looks like a very complicated step. Is there an easier way of doing it? Well, there is a pre-canned program in Excel that does it. So if I go to data analysis and I click on ANOVA single factor, I can pick the values right here. I included the names of the values, so I will say my labels are in the first row. My values are grouped in, which means the groups are by columns, not by rows, so it is in columns. I want my output, let's say, to be close to this number, so I can compare them, and I'll click OK. Now we see these are my summary stats. So I have 4 stores. These are the sum of each value and the average. I found the average up here, as you can see, 125, 109, and all that. Then my ANOVA, I tried to kind of make it look like the ANOVA that I have. Let me move this up a little more so we can see them all together. And so here we have the ANOVA among group, or they call it between group. The numbers are here. Within group, that's the number. We have our sum. The degrees of freedom. If you add these two degrees of freedom, you'll get the degrees of freedom of the total. We got our mean squares, which was just the sum of squares divided by the degrees of freedom. And then we found our F value, or the F stat, and the P value and the critical value of F. So you can look at this and we can make the same or get the same conclusion. Hope this was helpful, and I'll see you at a later video. Have a good day. Goodbye.